Hey students, in this video we are going to be looking at our next purpose of a mechanism. Our next purpose of a mechanism is to see if the mechanism is changing the speed of the movement. Learning targets that we'll be focusing on in this particular purpose of a mechanism is I can understand energy and the use of a mechanism to transfer energy. Also, I can recognize how mechanisms change energy by transferring speed. Hopefully, as I was reading those two learning targets, you are watching the two gears in the GIF rotate. These two gears are rotating in opposite directions, but they're not changing the type of movement. The question we're asking is, are they changing the speed of the movement? Are you watching the two gears spin in opposite directions, but at different speeds? So really what we do to figure out if a mechanism is changing speed, we are going to be comparing the output movement to the input movement, observing if they're rotating at different speeds. Let's look at that in another GIF. Changing speed. In this mechanism, we have two gears spinning. So are we observing a change in speed? Well, we're going to be comparing our output movement to our input movement. The question again is, do we see a change in speed? So, what's the answer when we're comparing the output to the input? Does this worm and wheel change the speed? Is my worm gear spinning differently than my wheel gear? The answer is yes, and ultimately it comes down to the number of teeth. There are a different number of teeth in a worm gear compared to the wheel. In our worm, we actually only have one tooth spiraling all the way down the length of that gear. In this wheel gear, we'd have to pause the GIF and count, but if I were to take a guess, I would say there's somewhere around 24 teeth. So there's a very large difference between 24 and 1. So speed is definitely changing. Looking at another mechanism, this is the bevel gear. For this particular bevel gear, we are going to be looking if we are changing speed. So we're going to be comparing the output to the input. Now, as you can tell here, I haven't labeled which is output and which is input. But the question is, does the bevel gear here change speed? The answer is no. In this mechanism, we are not changing the speed because the gears are the same size. When the gears are the same size, speed does not change. So, how do we guess if speed changes? We often can see the speed change. We can observe it with our eyes, or before we even watch it spin, we can make a guess based on the size of the two gears. So how do we do that? How do we make a guess? Here's how we do it. If the output gear is larger than the input gear, the speed will decrease. You can see in this chain drive, the speed is decreasing from the driver to the driven. The driver gear is spinning very fast, and the driven gear is spinning very slow in comparison. So in this mechanism, we are decreasing the speed because the output gear is larger. If we reverse the two gears, if the output gear is smaller than the input gear, we will increase the speed, as you see in the lower left corner of your screen. We have A spinning much slower than B. So we are observing and watching the two spin at different speeds. So how do we know if speed is going to change? How can we plan for it to change speeds. We can often see it change speeds, but how do we know without a doubt we're going to be changing the speed? Well, engineers know if they're changing the speed of a gear with different gears, but they also are going to plan on different speed changes by the number of teeth that they have. This is what we call a gear ratio. When we're making robots, when engineers are designing vehicles, they are always planning the gear ratio that they desire. So they sometimes plan for a change in speed, and they'll plan for that change in speed with gear ratios. May it be speeding up the gear ratio or slowing down the gear ratio. So again, we have to calculate that gear ratio, and we're going to use a mathematical equation to do so. The mathematical equation that we will use is down below. We're going to be comparing the number of output teeth to the number of input teeth. And engineers will often also use the diameter, the D, the diameter of one gear and compare it to another gear. So how do we do that? We're going to use the teeth. It's really easy to count the number of teeth on a particular mechanism to figure out if we're going to be changing speed. So we're just going to use one portion of the equation. So we're going to use the little gear as our input gear, and we're going to use the big gear as our output gear, and we're going to count the teeth. In order to count the teeth, though, we have to pause the GIF. Now I've counted the teeth for you. I counted on the driven gear, we have 30 teeth, and on the driver gear, we have 7. So let's plop those numbers into our equation. 30 and 7 are my number of teeth. The question is, which goes where? Remember that the little gear is the input gear, and on our equation we have IN to indicate input. So my input gear, 7, is going to go on the bottom, and 30, my big gear, my output or driven gear, is going to go on the top. For this particular gear ratio, we wouldn't have to simplify because we can't get 7 into 30 an equal amount of times without a decimal. So for class, we'll typically leave it as a gear ratio of 30 to 7. Let's try it again. In this mechanism, our simple gear train, we're going to be comparing our teeth. So we have to count them. Don't worry, I counted for you. On our driver gear, we have 30, and on our driven gear, we've got 20. We're going to plop those into our equation. Remembering that the driver is the input and the driven is the output. That means 20 is going to go on the top because that is our output, and 30 is going to go on the bottom because that's our input. The next step is to simplify. When we simplify, we get 2 to 3. That's how we communicate it. 2 to 3, and we write it as 2:3. Wait, what did I just do there? Why did I write it that way? Well, always when we're looking at gear ratios, we're going to write, calculate, and say the gear ratio differently. When you're writing a gear ratio in the written form, you'll write it 4:1. When you're calculating a gear ratio, you will always calculate it as a fraction, 4/1. But when you're talking to people about gear ratios, you're not going to say it 4:1 or 4/1. You're going to say a gear ratio as 4:1. So going back to what we were doing in our previous slide, I had 2:3, but I didn't say it 2:3. I didn't say it 20/30. I said 2:3. That's our gear ratio. But again, we're looking at, does this mechanism change the speed? And in fact, yes, it does change the speed because my numbers are different. So our third purpose of a mechanism is to change the speed of the movement, to change the speed of our movement. Your step is to now go on to Schoology and complete Quick Quiz 3.